it just says set up the integral on all these. So I'm not going to actually find them, so this won't take very long. Okay, so it says set up the integral that allows you to find the area in the first quadrant that is bounded by this y equals square root of x, and then this x minus 6. So we're trying to find this area right here. Okay, now we actually have to do this in two parts, so I'm going to back that up. And the reason we have to do it two parts is because from here to here, the graph is bounded by this y equals square root of x and the x-axis, okay? So let's highlight this. So from here, that is bounded by this square root of x and the x-axis. But on this chunk, it's bounded by the square root of x and this x minus 6. And because of that, we have to make two different equations. So if it's the shape is formed by different parts, you have to set it up in different chunks, if that makes any sense of how I just said that. Probably not. Okay, now it is clear that right there it intersects and right there it intersects. Again, if you wanted to find those and it wasn't clear, you can set them equal to each other and solve, but I'm not going to on this one. So this is the first chunk, this is the second chunk. I'm going to label it up here just so you can see. So on the first chunk, we're from 0 to 6. So my left value is 0, my right value is 6. And the only thing that's bounded by is the square root of x. It's always kind of bounded by the x-axis, so it's kind of assumed right there. So you don't have to put like the x-axis here is y equals 0, so there's no point of putting something in here. Okay. And then your second chunk is from 6 to 9. And this one's different because it's bounded between two graphs. And those two graphs are the square root of x minus. Now make sure you always put parentheses back here like we talked about in pre-calculus. And that would be the setup of the equation. If you wanted to clean it up, you could a little bit. But we're just setting these up. I think you can do the rest. I really do, I promise. And you would have square root of x minus x plus 6 dx. Okay, that's the only way you could probably clean that up. But that is number 3. So moving on to number 4. Okay, moving on to number 4. Let's see what this graph looks like. Okay, so it says f of x equals, or says set up the integral with the area of the region between the graphs of f of x equals 3x cubed minus x squared minus 10x. Okay, and then the g of x is a parabola, and it's opening down. Okay, so I need to move this a little bit. Wait, did I type in something wrong? Something seems off. No, okay. Oops. Okay, I'm gonna have to zoom out a little bit. So I'm going to do this again and take this picture and move it over here. Okay. Sorry, I should have had this set up beforehand, but it's okay. Whoa. Okay. So, whoops, the struggle. Okay, so this is our graph. Now, if you notice that they have two areas that are bounded, okay, so let's use the crayon, why not? So one area is right here. Ooh, I don't like that. That looks bad. Try again. We're not doing that. So highlighter. First area is this chunk right here. I don't like that either, guys. I'm sorry. I just can't. So this is one chunk. And this is another chunk. Okay. So we have two different integrals to set up, and we got to figure out where they intersect. So because we don't know where they intersect, we have to figure it out. So they intersect there. That one's obvious at 0. And this one probably is at 3, but we're going to have to check. So to do that, we got to set them equal to each other. So intersect. So we have 3x cubed minus x squared minus 10x equals negative x squared plus 2x. We're going to add the x squared over. If we add the x squared over, it goes away. which is easy, makes it easy, and subtract that over, so you get negative 12x equals 0. We can take out the greatest common factor of 3x, which gives you x squared minus 4. So this would give you x equals 0, and this would give you x equals plus or minus 2. Okay, so this one right here is negative 2. I was wrong, that was negative 2, not 3. Oh, positive 2, sorry. All right, so to set up the integral, so area is going to equal, this is our first chunk, our first and our second chunks right there. You're bounded from negative 2 to 0. And the question is, what's the upper and what's the lower? Well, the blue line is the f of x, and the green line is the g of x. So in this group right here, f of x is the upper equation. So you're going to do f of x first. So it's going to be, I'm going to put in parentheses, 3x cubed minus x squared minus 10x. And you're going to subtract. And the lower equation is the green line, which is the g of x. So that's the negative x squared plus 2x dx. So that's our first area. You would add the second area. I'm just going to put a 2 here, and we're going to set it up here too. I'm not going to clean it up. I'm just setting this up for you. You can integrate the rest. I really know you can. Now, if you notice on the second area, the green line is on top, so that's our upper bound. So we're actually going to put that first. So we're going to do negative x squared plus 2x. And the lower bound is the blue line, so then you do the 3x cubed minus x squared minus 10x. And then dx, and you would integrate. I would simplify these and then integrate them, okay? Last example, and this one is a little bit different, okay? So let's first talk about just how it's written. It says set up the integrals to find the area bounded by x equals 3 minus y squared and x equals y plus 1. So in all of our equations so far, it said either f of x equals g of x or y equals. So we all know that f of x, g of x are the same thing as y. Okay, but in this situation, we have x equals. So usually that's a really good sign that you're going to not be using the x-axis, you're going to be using the y-axis to bound it. But I'm going to explain why. So hint, it's bounded by y-axis if, and usually this is the biggest clue, it has x equals something for the equations, but if it's perpendicular to y-axis. Okay, so if you notice this area right here is bounded by this graph and this one, and we're going to break it down a little bit more. I'll try to explain it as much as I can. So this is the area, right? That's the area bounded by these two graphs. So if we were to try to do it with the x-axis right here, okay, if you notice you have this graph, you could break it down here, and you'd have, this would be the upper and this would be the lower. But if you went to go here, you'd have to break it again, and this would be the upper and the lower. So I guess we didn't really need this right here. This right here could be the upper and the lower. But right here, it's not a function. Okay, and it's not a function because it fails that vertical line test, so that's another hint. But you don't have an upper and a lower, you just have one function as a whole. So if you have one function as your upper and your lower, it probably means you have to go around the y-axis, or if it fails the vertical line test. It probably needs to be bounded or it's the y. So ignore these lines. Let's see if I can get rid of them actually. Yep, okay. We need to find this. So we're going to use, I wish you could just, if you could take your screen and just turn it to the left and think of it vertically, it looks just like what it would be on the x-axis. And that's how I visualize it, or like turn your head and think of it that way. I don't know. Try something. It's weird to visualize. So since we're using this as the way we're bounding it, we have to think of not, so if it's about the y-axis, you're not thinking lower or upper, you're thinking right minus left. Okay, you can still think of it as upper minus lower, and I would think of this as the upper if you turned your head and this is the lower, okay? But it's a lot easier if you do the right minus left. So right here, this function is the 3 minus y squared, and then this function is the y plus 1. So the upper, or the right function, would be the 3 minus y squared minus the y plus 1. And because these are y's and we're doing it about the y-axis, you have to put dy. We're integrating with respect to y. So then the question is what about the bounds? Well, what's the lower y value? Well, the lower y value of where it's bounded is -2, and the upper y value is 1. So these values right here depend on how you're integrating it. So if you're doing it with terms of dy, then it's y terms, and if you're doing it with respect to x, then these are x values, okay? And that's how you would set it up. I imagine there's a lot of questions, so get on this today, and Friday we'll do a help session, all right? Stay safe, stay healthy. See you later.